All right. Well, I hope that everybody is having a good day. We're going to go ahead and quickly wrap up the final problem on the assignment. Then we'll go ahead and get that turned in, and we'll start conditional probability. Just kind of give you an idea of what's going to be happening. Remember, tomorrow we're going to have a little quiz over this material, just simple probability. Next week, of course, you don't come on Monday. You got yourself a 3-day weekend because we have professional development. We're going to continue working probability all of next week, and it's probably going to take the majority of that time simply because there's a lot to talk about, and a lot to practice. But I want to kind of let you know what's coming up on the horizon. 2 weeks from tomorrow is already the end of the 6 weeks. Okay, so this is already the third of the 5th week. So on Monday, the 28th, that's when we're going to have our second exam. Okay, so it's not going to be ideal, but we're going to have a very small window if anybody does happen to score below an 80 and is wanting to retake, just because I'm going to take care of grades on that final day. So the closer we get, I'll be giving you a little more information. But that exam is going to be over probability, all aspects of it, from simple probability, tree diagrams, lattice diagrams such as this one, to what we're going to go ahead and start talking about today, conditional probability, and even comparing some ideas like mutually exclusive versus independent. Okay, so we still have a good, week and a half before that happens, though. Are there any questions about what's coming up? All right, well, let's see here. Number 6, a pair of dice is rolled. The 36 different possible results are illustrated in the two-dimensional grid shown. Use the grid to determine the probability of getting. All right, well, why don't we go ahead and get some folks up here to do a couple of these. We'll have someone work like A and B, and then C and D, and then the last ones. Okay, so who would like to help me out with A and B? You want to do the random number generator? That sounds like a very popular idea. Okay. All right. So let's see here. Random number generator. And in here, I think Kate is in seat 34. Okay, so 34, unless I have a volunteer. So many hands, I don't know how I'm going to decide. Okay, generate. 1. All right, Jacob has volunteered to help me with 6A and B. Yes. I haven't gone through it yet. There's a possibility it's still in the tray. Remind me at the end, and I'll double check that. Because I could have sworn I put that in because I remember checking it. Yeah. We'll check. Remind me at the end. We'll check. Okay. Okay. Wow. I didn't even see him because I was having a conversation with Jaylee over here. So he says 1/36 and 1/18. I will say one of those is correct. Okay. B is 1/18. That's exactly right. Because it says a 5 and a 6. Okay. Well, Jacob changed it. Jacob, do you know why it's actually 1/18? Yeah. Okay, why is that? That's exactly right. Okay, so let me kind of verbalize what he just said because you can't probably hear it on the mic. So you're rolling a pair of dice. So we want a 5 and a 6. So the first die could have the 5, while the second die could have the 6. So we could be looking at this one right here. Or it could work the other way. The first die could have the 6, and the other one could have the 5. So there's 2 ways out of the 36 in order to get a 5 and a 6. All right. So 2/36 is where we get the 1/18 from. This one here, you want 2 3s. Well, there's only one way for that to happen. Okay, one dice is 3, the other's 3. It's that one right there. Okay, so any questions? All right, who would like to help me with C and D? A 5 or a 6? At least 1 6. Okay, random number generator away. Let's see what we got here. Generate. It's thinking. Oh, God. I'm just kind of curious. If I click it again, will it say 3? Okay, there we go. Now it's actually starting to get random, but it did say 2.
Oh, but it says 9 now.
Oh, I was just checking it. All right. Emma's going to help me out on this one. Okay. Okay. So we want the probability of rolling a 5 or a 6.
I do that right. I feel like it's either 20 or 21 on this one. I feel like I'm second guessing myself.
So 20 out of 36. Okay. And what would 36 reduce to? Okay.
And then at least 1 6.
At least 1 6. Okay. So she's got 11 out of 36. What do you guys think? She is correct. There we go. Okay. A little hesitant there. So good job, Emma. Okay, so how do we get C? Now, think about those key words here. And means we have to have both of them at the same time. But or, it could just be one or the other. Remember, think about the idea, because we're going to start relating this back to sets later today when we get to conditional probability. But all I need to roll is a 5 or a 6. And it doesn't matter which die is going to do that, right? So on each die, I could roll a 5 or a 6. So I'm looking at all of those right there. Okay, so how many dots do I have within these regions?
I guess 20.
There is 20 there. There you go. 20 out of the 36. Because the first die could roll a 5 or a 6, and the other die could roll a 5 or a 6. So there are 20 favorable outcomes where we have one of the two. Okay, we don't have to have just both. We could have one or the other. Does that make sense? Okay. Is everybody okay with D? At least 1 6? Now, again, the wording is very particular here. At least 1 6, so it is okay if what? If there are 2. Okay. So, Emmy, are you having trouble?
Oh, I thought we were
On
talking
D?
about E the whole thing.
Oh, no. We're still on D. So, Emmy, are we okay?
Yeah, I'm good.
Okay.
No,
All right. All right. Good. Okay. And our last pair. E exactly 1 6 and F no 6s. Okay. So again, any volunteers? Okay. Now I did pull up 9. Unfortunately, John Henry is not here today. So let's see. Generate. 18. Oh, Nolan is not here. 32. Oh, nobody sits in that last row except Cade. He's 34. Woo, this is exciting. 3! All right, Emmy. The smile on her face says it all. Okay, there you go. So the probability of getting exactly 1 6. There you go, ma'am. Oh, that's okay. So 5 out of 36, and then no 6s, 25 out of 36. Okay, so just like Jacob, I will say one of those is correct. Which one do you believe it is? F is correct. Okay, the probability of getting no 6s is 25 out of 36, but exactly 1 6. Anybody? Okay, Joey, what'd you get? That is right. 10 out of 36. Oh, Emmy's walking away. Okay. Emmy, not going to write?
Nope, I'm good.
Okay. She's like, I'm done. All right, it is 10 out of 36. 10/36, which is 5 out of 18. Okay, so let's talk about this for just a second. Okay, exactly 1/6. Where are these 10 coming from? Yeah, because think about one die. If it does happen to roll a 6, that means the other die can roll anything 1 through 5, just not a second 6. Or you could look at that from the other die's point of view. Okay, you could roll a 6 on this second die, but then the other one would have to be 1 through 5, as long as it's not both right there. So the 5 plus 5 is where we got the 10 from, out of the 36 total combinations. So we okay with that? Okay. Now let's talk about no 6s. Where did we get the 25 from? Yeah, whatever you roll on one die, as long as you get no 6 at all. So all of those are eliminated, all of these are eliminated, and you'll notice you've got 25 left out of your sample space. Okay. How many people had all 6 of those right? Ooh, okay. Couple folks. What about 5? Okay, more hands are going up. 4? Okay, good, 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 good. Okay. Are there any questions? Okay. Then make sure your name is on that. Let's pass it on up to the front, please. And let's start talking about some conditional probability. Thank you. Thank you. Oh, thank you. Thank you. Thank you, sir. Appreciate it. Okay, any others out there? Ella, did you just make a loud noise?
I did. I got a water bottle.
Oh, I guess I didn't hear it. Oh, check it. Thank you. Okay, good, good, good. That's a lot of homework. That's what I like. See you guys next fall. Okay. See, that should have been our TikTok. What? I'll tell you what, we'll stop early at the end and we'll do it. Okay. All right. Oh, but speaking of, how many hits did we get? What?
You have to understand that.
I did Saturday Night Fever in the hallway and we didn't post it. Oh. What? Whoa. Whoa. Okay. Well, hold on. This can mean one of two things. So by quality video, do you mean you're still in the process of editing it, or it's just never going to be posted because Mr. West?
I'll post it.
Well, I thought that's what we were going to do.
Okay.
And we were going to go viral. We had a plan.
We have a point.
Oh, I'm good on that.
She'll post two. She'll post them and I'll post them, so then we have to get.
Okay. So you had decided not to post it?
Well, I did.
If you don't want to, you don't have to.
No, I posted it.
I'm completely. Yeah, Elizabeth's over here. Why haven't you posted it yet?
Credit to Ella. Ella was when he made the joke.
Okay. I'm looking forward to the day when I walk along the street and some little kid goes, "You're a horrible dancer." He'll know me. Okay. All right. Well, let's go ahead and get going here. Let's see. We're going to talk about conditional probability. Oh, there you go, man. Mm-hmm. So let's see. This chart at the beginning of your notes does a really good job of combining what we're going to be talking about with what we have been in the previous unit, where we're talking about sets involving the complement, intersection, union, all those good ideas here. Okay, make sure I get my notes. Okay, so the complement of A, denoted with that little tick mark. Remember, this is everything still in the universe, but outside of that particular set. All right, so we've got the shaded region right here. So when it comes to probability, the probability of a complement occurring is 1 minus the probability of A. And again, what does 1 represent? Okay, well, not the universe per se, but 100% probability of that event occurring. Remember, our probabilities from the lesson we just finished up are going to be between 0 and 1. Okay, I mean 0 meaning no chance of that event occurring, and then all the way up to 1 guaranteed. Remember? Yeah. All right, there we go. All right. So probability of A complement is the probability that A does not occur. Now the intersection of A and B, okay, this is the upside down U here. This is the intersection of sets A and B, that is the set of elements belonging to both the set A and set B. So shading wise, where we're going to look for the overlap. Okay. That's going to be really important to us today, especially when we start talking about an idea called conditional probability. The union of events, A and B. Union of sets A and B, that is the set of elements belonging to A or B, or both A and B. Remember, this is what I referred to as the marriage. What should I shade here? All of A and B. There we go. So nothing outside of those sets. So I'm just going to go ahead and shade these guys like this. Okay, so then we have one of these rules that we saw in our previous statement. The probability of A union B is the probability that either A or B or both occur. From this, we have what's known as the addition rule. So you'll notice the probability of this union is the probability of A plus the probability of B, but what are they subtracting here? We're subtracting the probability of the what? The intersection of the two. Because remember, where they overlap, you're going to have elements common to both A and B. We don't want those counted twice. That's why we're going to go ahead and subtract those off. All right. And then we have down here, if A intersecting B is equal to the no solution, okay, the null set, empty set, we can call that disjoint. They have no elements in common. Okay, this is what we refer to as mutually exclusive. Yes, ma'am?
I know this is something we probably already got, but if we subtract all of the intersection, doesn't it get rid of the entire stuff of data, or is it still?
No, because let's say you were to go ahead and separate the two ovals, then you're going to have the same elements in each. So when I take the union, we don't write those twice.
You just write them all.
We just write them the one time. So that's what this is doing. Okay, it's just taking care of the idea that while we are still counting elements that occur in both of the sets, we're not counting them twice. Does that make a little more sense? Okay. All right. Now, if A and B are mutually exclusive events, that means they have no common elements. In terms of probability, that means we don't have favorable outcomes that can occur at the same time. All right. That is, the number of elements in the intersection is 0. The probability of the intersection occurring is 0. So thus, the probability of the union is just the probability of A plus the probability of B. So you go ahead and compare this to the previous one. Because there's no overlap, there's no need to go ahead and subtract any common elements because there are no common elements. And here we're talking about favorable outcomes. Okay, so let's try a couple of these. And on these, I strongly recommend, especially in the beginning, probably a really good way to do these is to create a Venn diagram based on the information that you're given. So let's see here. If the probability of A is 0.35, the probability of B is 0.5, and the probability of the intersection is equal to 0.15, find the following. Okay, so let me go ahead. Let me try to make this look somewhat neat. That's not what I wanted. Okay, let me go back over here. Was there a, oh, here we go. That's what I need. Much better. Okay, so now we just got that tiny little box there. We'll just ignore him. Okay. All right. I'm not going to worry about the two circles. I'm just going to go ahead and draw them. Yeah, actually, those are good circles, huh? Good. Okay. So let's say this is A. This is B. I want you to take about 30 to 45 seconds, fill in the appropriate information. Remember, the entire rectangle should represent 100%. In this case, of every outcome. That's my sample space. Okay, so I'm going to go ahead and start where I believe probably a lot of people did. We know that there is an intersection. Okay, so what would you say? These are or are not mutually exclusive? Remember, what does that mean? If I come back up here to the table, mutually exclusive means they what? They have no intersection. There's no common elements. But according to this, there is an intersection. So what would I say about this? They are not mutually exclusive. Okay, because they have an intersection, because they have common elements, okay, or in this case, probability, it is not mutually exclusive. Hello. Okay, so I'm going to go ahead and put the point 15 right here in the middle. And see, from this, I can go ahead and start to work my way out and fill in all the other areas. Now, I know that what's the probability of A? I know that's 0.35, right? But I've already accounted for 0.15 because of the intersection. So what should go here in strictly A? 0.2. Because the 0.2 plus 0.15, that will give me the 0.35 total. And let's do the same thing for B. I know that the probability of B occurring is 0.5, so what should I put here? 0.35. Okay. Am I missing anything? What am I missing? Okay, now the universe, remember, we said has to add up to 1. So what am I up to right now? Okay, there you go. So somewhere inside the rectangle, but outside of A and B, I want to go ahead and put 0.3. Is everybody okay where Elizabeth got the 0.7? Do I need to elaborate on that? I will, just in case. The 0.2 plus the 0.15 plus the 0.35. Okay. So now, why don't you go ahead and try these three on your own? Okay, 1, 2, and 3. What's the probability of A's complement? What's the probability of the union of A and B occurring? And what's the probability of the union of A and B's complement occurring? Okay, let's go around the room. Let's see what we got. How about, who haven't I talked to recently? Kate, what would you say the probability of A's complement is?
Would it be 0.65?
It is 0.65. There you go. And again, a couple of different ways you could do this. If you really like the diagram like I do, you could just go ahead and shade everything outside of A. So the only thing outside of A, I got a 0.35 plus 0.3. That's where we got the 0.65. Or you could go ahead and try to come up with some kind of expression. Because we're talking about the complement, this is equivalent to saying 1 minus the probability of A. All right. So 1 minus 0.35 is still going to result in your 0.65. So see, there's always going to be multiple ways you could look at this. How many people got the first one right? Okay, so that's okay. A little bit of practice. Let's try 2. Jaylee, what'd you get for the probability of A and B's union? 0.7. There you go. Okay, that's exactly right. Now, because these guys are not mutually exclusive, again, you could have chosen, if not looking at the Venn diagram here, if you just went ahead and shaded in A union B, 0.2 plus 0.15 plus 0.35, you could have gone back up here to your table and then use this particular formula right here. Okay, subtracting the intersection, again, because they are not mutually exclusive. All right. How many people got 2 right? Okay, so definitely way more hands on that one. Now let's talk about 3. The probability of the union of A and B complement. So by show of hands, who believes they have this one? Okay. So Katie, what do you think it is? It's not 0.2. It's a little more than that. Okay. Emma, what do you think?
0.8.
0.85, that's a little high. Okay, we're getting close. Stephanie. Oh, we're still not quite there, so it's a little low too. Cortland? 0.65. 0.65. Okay. So when you're looking at these kinds of ones, especially again, like me, if you're going to go ahead and just shade it in, well, the first thing I'm going to do, I want A union B complement. So I'm going to go ahead and shade in A first. Okay. But then I want to take everything outside of B. Now remember, in this instance, even though the intersection belongs to B, we're still going to include it in that union. So I'm going to go ahead and shade everything else. So what's the only thing I'm not including here? The 0.35, the difference of that from 1 is we get our 0.65. How many people had that third one right? Okay, that's good. That's good. It just takes a little bit of practice. Now, algebraically, that one, I don't know that there's an expression right off that would lead us to that. Probably, honestly, that one I would have to think about it. I don't have an answer right off the top of my head.
I put
Mr. Oh, do you have one?
no, it wasn't correct. I ended up with 0.7.
Okay.
It was 1 minus probability of B plus the probability of A minus the intersection.
So say it again.
1 minus the probability of B plus the probability of A minus the probability of A intersection.
So let's see here. So you're going to take off the probability of B. So that's going to be 1 minus 0.5 plus the probability of A 0.35 minus the intersection. But okay, the intersection being 0.15. It's 0.55. That gives you 0.7. So it's close. I didn't even think about that off the top of my head. I'm not sure. Mr. Yacht, do you see one right off the top of your head?
It's like a combination of the first two.
Okay.
Actually, the probability of B is 0.5. So then you do 0.5 plus probability of A.
Probability of A, so 0.35.
And then that intersection of A
And then minus the intersection, 0.15. Because
that
that should give me 0.7.
should be the intersection of A and complement B.
Okay. Let me work on. Or do you think you got it?
Yeah,
Okay.
like if we go back to this thing, it's these two. It's the intersection of. It's the intersection of. So if you go to here, it should be the.
Oh, I see what you're saying. The intersection. Okay, okay.
Which is 0.2.
Okay. Yeah. Okay, there we go.
But how would you know that algebra?
That one I don't think is a direct one. Like, I think you could just probably work it out like Mr. Yacht did.
Yeah, I did it earlier.
Did you? Okay.
That was it.
Yeah, other than that, that one's not like a direct formula, for finding that specifically. Probably because it is somewhat random, given that one of them is a complement. Okay. Does that make sense, though? Yes? Okay. Why don't we go ahead and try another one? Oh, yes, sir.
Get the probability of A intersect complement of B because that's the purpose. That's this part.
Uh-huh.
This is the part that's A intersect B. This 0.1 or 0.15. The rest of it intersects the complement B.
Yes.
Yeah. So that's how I got the 0.2.
Okay. All right. Cool. Thank you. All right. Any other questions? Good, good, good. All right. Let's try this one. A bag has 20 coins numbered from 1 to 20. A coin is drawn at random, and it's number noted. What's the probability that the coin has a number that is divisible by 3 or by 5? So notice I've already got this set up, and we know immediately this is not mutually exclusive because is there a number that is both divisible by 3 and 5?
Yeah.
Which one? Okay, 15. So I'm going to go ahead and put him right here in the middle. So let's say this one here is the divisible by 3. This one here is the divisible by 5. And we can probably name those if you want to. I'm not worried about that. Okay. So let's go ahead and just start. Well, 1 is neither. Okay. 2. No. 3. Okay, we go here. 4. 5. Then we got 6. Okay. Oh, I was just saying if y'all were paying attention. Hey, look at that math. Okay. 7. Okay, then we got 8, 9, 10. Ugh! I'm going to sit down. I'm just counting. I'm a math teacher. Okay. 11, 12, 13, 14. Ha! Got 15. Damn it! Mr. Yacht, you want to take over? Oh, obviously. Okay. 15, 16, 17, 18, haha, 19, and 20.
Wow.
Thank you. Thank you. Your math teacher knows how to count and divide. That's awesome. All right. All right, so is everybody good with how I set this up? All right. So what is the probability that the coin has a number that is divisible by 3 or by 5? Well, look at the way that I organized it. 3 or by 5, okay, can include 1 or both, right? So how many elements do I have total here that is divisible by 3 or 5? 9. Okay, so 9 out of 20, and that's not going to reduce, so the probability of finding a value divisible by 3 or by 5 is 9/20. Okay. All right, now what I did in this lesson was after certain problems, I went ahead and supplemented it with extra examples just to go ahead and get extra practice. So there are going to be problems I'm going to be showing you that are not in your notes. Okay. If you want to go ahead and copy this down, you're more than welcome to. If you just want to follow along, that's perfectly fine as well. But I'd like someone to help me solve this one. Okay. And based on my performance on the previous example, it's probably a really good idea. All right, so let me read it out to you. In a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both of these subjects. Display this information on a Venn diagram and hence determine the probability that a randomly selected class member studies, and then we have everything from both subjects to neither subject. Okay. So I'll give you, let's say, a minute or two to go ahead and kind of get your Venn diagram together. Once you organize all the information correctly, pulling that information off of it becomes a lot easier. Okay, so let me give you a couple minutes. You can also go ahead and kind of discuss this with your villain buddy, see if you're getting the same type of diagram. All right, just so everybody's on the same page, let's go ahead and say that this left circle, that's physics, and this one will be chemistry. I mean, ultimately, it really doesn't matter, and we're in a class of 30 students. All right, now you may not be done, and that's okay, but who would be willing to come up, fill in the Venn diagram for me, and then find the probability that a randomly selected class member studies both subjects. That one you could probably get even without the Venn diagram. Okay, so who can help me with this one? Or do I need to go random number generator? Random number generator. Okay. Generate. 18. Didn't we already do that one? This is not a very good random number generator. 14. 12, 13, 14. Joey. Okay. All right, and here's the pincer. So where should we start on this Venn diagram? Like, what do we know for sure? Okay, 15 study both, so where would that go? Okay, so that's the intersection. And now we can just start to branch out into either of the other two sets here.
So if I take some physics, 19 minus 15 is 15.
Okay.
Okay.
What
Scared.
what happened? What happened?
Am I doing it wrong?
No,
Wait, so what am I
there's only one thing wrong with it, but I don't think it's that fun.
is it
What's going on?
I blew a bubble and it deflated, and I put it back in my mouth and she laughed at me, and I said, "Ew, gross." And then he turned around and went.
I didn't hear that part. I just sort of did it.
I thought that you thought that I was calling it.
Oh. Okay. For the record, Joey, no one here thinks you're gross.
Joey, I think you're quite great.
Yeah, and he corrected the one mistake
Am I
too.
answering A's?
So you'll answer A. There we go.
Okay. Wait, no, it's probability. So, out of 30.
So study both 1/2, because there are 15 out of the 30 that study both. Now, is everybody okay with where we got those numbers from? Like especially the 9? Any questions on that? Okay. All right, so I'll tell you what, we'll go ahead and stop there today, because I said we would. So tomorrow when we come in, we will finish up this problem, and then I will introduce you to conditional probability. Emmy, you don't understand what?
It's been a really rough week, so.
It was a rough day.